quadratic binary field, deterministic computation producing quantum-like effects. The quadratic binary field introduces a first principles computational architecture in which binary values do more than occupy memory addresses. They exist within a structured field of spatial relationships, unresolved potential, contextual states, deterministic walkers, and lawful transformations. Built entirely in executable classical software, the system demonstrates that carefully designed binary mathematics can produce reproducible quantum-like operational effects, including observation condition materialization, contextual overlap, path-dependent outcomes, order-sensitive projection, unresolved state, root-based memory, and the emergence of committed information from a prior field of potential. The architecture transforms computation from a hidden sequence of internal operations into a visible journey through a three-dimensional field evolving across phase and time. Information can be written into the field, encountered from different directions, transformed through neighborhood relationships, preserved as static memory, reconstructed through stored paths, and executed as spatial programs. A route can become a read order, a journey can become memory, a persistent path can become an instruction sequence. Multiple walkers can traverse and operate upon the same field while retaining their individual histories, permissions, conflicts, and contributions. One of the project's most significant achievements is complete causal inspection within the declared computational system. The quadratic binary field preserves the full chain between input and result, spatial placement, available candidates, walker decisions, observations, unresolved coordinates, materialization events, memory writes, refusals, commits, conflicts, outputs, and provenance. The result of a computation is therefore not only its final binary stream. The result includes the entire causal pathway by which that stream came into existence, visible, replayable, testable, and open to independent verification. The paper combines technical specification, mathematical theory, experimental biography, benchmark evidence, visual trace analysis, and reconstruction guidance. It follows the project from its earliest binary heartbeat through observer materialized potential, exact field memory, Hath readback, persistent root reconstruction, bounded spatial instruction execution, transactional recovery, multi-walker computation, orientation index states, binary interpretation, and a working field-backed object vault. The result is not merely a proposed theory, but a theory expressed through functioning software, controlled experiments, preserved failures, negative controls, and repeatable benchmark achievements. The publication is accompanied by the complete project benchmark and reconstruction archive, source code, version contracts, tests, verifiers, locked benchmark roots, state tensors, event traces, origin maps, transaction journals, manifests, checksums, interface assets, visual records, and reproduction procedures. Together, the paper and archive are intended to provide a complete technical inheritance, sufficient for independent researchers, engineers, and advanced AI systems to reconstruct the architecture, interrogate its claims, reproduce its experiments, and carry the discovery into directions beyond those explored by its originators. The quadratic binary field also opens a serious research path toward more efficient forms of classical computation. Its use of unresolved sparse state, lazy materialization, reusable paths, event-based memory, local neighborhood operations, contextual multiplexing, and procedural reconstruction may lead to systems that reduce unnecessary memory allocation, stored intermediate state, and data movement in suitable artificial intelligence, simulation, storage, and data center workloads. More broadly, it offers a foundation for machines that do not merely compute results, but preserve uncertainty, remember where information came from, refuse unsupported actions, recover their own history, and reveal the full structure of their computation. At its core, the quadratic binary field presents a new computational principle. Information is not only a value. It is a value in position, in relation, encountered through a path, observed within a context, preserved through time, and made meaningful through evidence. This is the field beneath the data, a deterministic classical structure capable of producing quantum-like effects while allowing every step of its operation to remain visible.